Today is going to be a brief demo on how to use RStudio Cloud to analyze the results of our sequencing experiment. So first we want to click on this link to RStudio Cloud.
For this lab, we're going to be using some online data resources, and one of those is going to be a tool called RCloud. R, for those of you who've already taken Stat 250, are probably familiar with it, but for those of you who haven't, is basically a statistical programming framework and programming suite that you can use to analyze all types of data. One of the great things about R is that it is an open source tool, and you can install it on your own computer. But given that people might have issues installing on your own computer, and to get around those for the limited time that we have in this class, we're going to be using this tool called RStudio Cloud because it'll all just be one installation that we can all use. So one of the nice things about RStudio Cloud is that we can use it as a free resource, but we do have to do a few things to make sure that we can use it for free. So just to get started, we'll click on this Getting Started for Free component, and you can see that you can make limited use of RStudio if you can sign up, right? And so there's some limitations on here. Obviously, our class is much bigger than this, so in order to save everybody money, you and me and the university, and you so you don't have to pay lab fees, we're going to have you sign up for one of these free accounts. So go to one of these sign up links. You'll then enter in an email address. A password that you would like to use, and then your first and last name. And then hit the sign up link. Once you've signed up, you'll get a little name that you can have associated with your account. This is what mine's going to be, and then you're going to create your account. Oh, looks like I already probably created one of these, so we'll just say and now we have the account. You'll see the number of projects you have, what your usage is, and now we'll be able to use our cloud. So to start using our cloud, one thing that we'll want to do is create a new project. So there's a little blue button up here in the right-hand corner. We'll click on that to create a new project. Once that's done, if you want to see your other stuff, other information, you can open up that little menu over here. And we can also change the title of the project. So I'm just going to call this Bio 210L Genomics, so I can see it. And how our cloud works is that we want to upload our data file over here and then run our commands in this console window over here. So first I'm going to upload the file. And what I'm going to do is I'm going to upload the file of the sequence lengths, which if you go to the iLearn page, there's a link right here. You would go to this location to download this file. So you'll have to download it. It's actually quite a big file because there's a lot of things in there. So it'll take a little bit of time to download. So please keep that in mind. So you'll download this file. It's just a text file, so there's nothing fancy about it. So after you downloaded that file, you'll then have to navigate to wherever you downloaded that file was. I have it in this directory. You might have it in your downloads directory. So I'm going to open that, hit OK, and then it's going to upload. And this might take a little bit of time for the file to upload.
There's a lot of different ways to interact with R. This is a version called RStudio, and we're going to be using this command line interface over here to interact with our data. And the reason why is because a lot of scientific computing is done in command line environments. So I think it's a good idea to get you guys exposed to it early so that you can learn about it and become more comfortable with it, because that's one of the most difficult things to do. So if you need any other background on how to use this space, there are some guides and some primers and some cheat sheets over here on the left that can be very helpful in learning how to use RStudio Cloud. So for our intents and purposes, I've uploaded a sequence lengths file into our working directory. So if I was to see where I'm at, I can type a command called get working directory, and that tells me where in this cloud environment I'm in. I'm in the projects directory, which we can see here, and in that directory is something called sequencelengths.txt, and that is a data file with the lengths of all of the sequences from our sequencing project. So if I want to import that data into my R environment, I need to use a command called read table. And this will read in the text document and insert that information into an object called data. Once I have this file imported into my directory, I misspelled the name up here, so that's why I had to fix it. I can take a look and see what it looks like. So if I just use this head, I can just look at the first few lines of this data object, and I can see that it's basically an object with one column of data in it, and each of the entries in this column represents the length of a DNA sequence from the sequencing experiment. So this column 1, or V1, right, has all the different lengths of the sequences. So first thing I might want to do is I might want to try to figure out what is the total number of sequences that I had in my experiment. To do that, I can use a command called lengths, and I can figure out how long is how many entries are in this column. So how long is this column? To do this, I need to isolate the information just in this column. So if I just type in data, it's not going to like that. It's just going to say, well, it's only one thing long. That's because it's only looking at the column in and of itself, right? So it's only got one column. So if I actually wanted to look at a specific column, there's kind of two ways I can do it. Here I can say, I can use a coordinate system and say, look at bracket position, comma 1. And so this means the first column. If there are more than one column, I can put a 2 there, and we'll look at that. So this will tell me exactly how many sequences are in my sequencing run that I have lengths for. So here there's about 2.5 million sequences that we got from our sequencing run. If you ever want to get code back, you can just hit the up arrow and it'll come back. So if I want to make a change, I can hit the up arrow. And then there's another way that I can identify columns too. I can give it the name of the column. And here I can say $ name of the column, and it'll give me the same number. So now I know how many sequences are in my sequencing run, and I can start to think about what are other ways that I can summarize this experiment so I can understand it. I can compare it to other sequencing experiments. Other people can look at my sequencing experiments and learn something from it. This is an important part of communication in sciences, using data and quantitative information to communicate information and interpretation about results. So what else can we calculate here? Well, we could see how much sequence did we generate. So if we think about the number of sequences, what about how many base pairs did we actually sequence? So here we could use the sum command to calculate the total amount of sequence that we've actually generated. And we can even put it on the scale of megabases. So if we think of kilobases being thousands of base pairs, megabases are millions of base pairs. So we can think about how many megabases did we actually generate. We can divide this number by 1,000,000, and we can see that we sequenced about 2,605 megabases of DNA sequence. So that's quite a bit of information that we generated in this period of time. We generated over 2.5 million sequences, of which they accounted for over 2,600 megabases, or 2.6 gigabases of data. We might be curious about what's the longest sequence that we have. We can identify that by using the max command, which tells us that the longest sequence that we sequenced was almost 44,000 base pairs long. We can calculate what the average or mean sequence size was of every sequence that we generated. So here we can say, what's the mean? Right? The mean is just a little bit above 1,000 base pairs. And we can say, well, how variable were these results? We can look at standard deviations and look at that first column. And again, here we can show, oh, the standard deviation is actually even wider than the mean. So it looks like there's a lot of variation in this data set. Highly variable data set. In addition to the mean and standard deviation, we can look at another moment of the distribution here, and we can say, what is the median of this data set? And the median refers to the value which is sort of the most frequently observed value in our distribution. So notice here the median is actually less than the mean. And that means that what we're probably looking at here is a distribution that is skewed, that doesn't look like a normal distribution or a bell curve, and it's a skewed distribution. So how can we visualize this distribution? A classic way to look at a visualization of data is to use a frequency histogram. And these are very easy to generate in R. So we're going to use a frequency histogram here to generate, take a look at this data and visualize it. And we can see I generated a frequency histogram, and it pops up over here. You can see it looks like I have a lot of observations. Looking at the frequency of observations over here. The frequency of observations are very high for sequences that are rather small. But you can see it goes all the way up to 40-something thousand because that's my largest sequence, right? So it kind of has this decreasing curve look to it. But this isn't kind of the prettiest graph that I could think of or present. So I could do some things, like I could add some color to it. right? I can make it blue, but still, you know, this isn't really all that informative. It doesn't really look all that good. Um, you know, the x-axis isn't really broken up. This is a really big bar. I can't really see much detail here. So maybe I wanted to, I'd like to change the x-axis and look for not maybe from 0 to 40,000, but maybe just to 20,000, right? Still, I'm not seeing that much, so maybe I even want to shrink it down farther to 10,000. Right, so now I'm starting to see a little bit more resolution here, but notice like everything from 0 to 2,000 is all together, and everything from 6,000, 8,000 is all together. So I still can't see a lot of resolution. To improve that, I can make more bins. So I can make it instead of there just being 5 bins here, I can increase the number of bins. And I do that using a command called breaks. So here I can increase the number of breaks, and now we can see I'm starting to see a little bit more definition here, and I can even increase it further and get more definition here. So now I'm starting to see a little bit more of the detail in this figure. Still a couple things aren't that perfect. You know, this label is not a very good label, so I could say, hey, let's make this into make a prettier figure. All right, there we go. That looks a little bit better. And then, you know, even further, you know, most of figures that we see in scientific literature, they don't have these kinds of weird titles in them, so we might want to get rid of that title as well. So there we go. You've got this beautiful looking figure. We might want to take some time to export this and put it into a document, giving it a proper legend that describes accurately what it is. So what we'll do is we'll save this image, and you can copy it, you can save it as a PDF, you can save it as an image. I'm just going to save it as an image. I'm going to call it sequence frequency histogram. And I'm going to want to see it after I'm done. I can change the aspect if I wanted to here. I could make it a little bit, make it look a little bit different. Maybe I want to make it less wide. I can shrink it as well. There are various things that I can do to make it more palatable. Save it as a PNG, and there it is. If I go back to my environment now, I can find my files, right? And here is my file right there. And if I want to export it, I just hit export, and now I can download it. And I can see it on my figure. So there we go. That's how we would make a frequency histogram in R, as well as generate some summary statistics which can help describe how we think our sequencing experiment went.